forward to his update on the TMDL study underway for the Wisconsin portion of our watershed. And here he is.
Thank you. Good morning, everyone. I'm here to give you just a quick update on the TMDL that we're developing for the Fox Illinois River Basin in Wisconsin. Okay, so before I get started into the TMDL specifics, I want to give you an idea about the project setting. So this is where we're working for this specific project. The map you can see on the far left shows the boundaries that we're looking at. Within Wisconsin, there are 4 primary counties that the study area overlaps. These are Waukesha County, Walworth, Kenosha, and Racine. There's also a little bit of the watershed that overlaps 3 other counties, but those are pretty minimal, so we're really focusing in on these 4 counties. And within the watershed, we have 7 kind of sub-watersheds. So the largest watershed we'll be looking at is this Fox River watershed. It's the largest one, shown in blue. We'll also, as a part of this project, be evaluating the Des Plaines River. We're looking at the headwaters of Nippersink Creek, the North Branch of Nippersink Creek, North Lake, Channel Lake, and North Mill Creek. The reason we're looking at all of these under the Fox Illinois TMDL is we're going to all this effort to develop a model and develop the allocations for this TMDL. And it just makes a lot more sense for us to cover all of these areas that are adjacent to the Fox River. So to give you an idea of the status of the water quality in this basin, this map shows you the TP impairments, total phosphorus impairments that we currently have. So the red lines show you all the reaches that are currently listed as impaired for the for phosphorus. There are 11 named streams and rivers, the biggest one being the Fox River. Also the Des Plaines River is listed for phosphorus as impaired, the White River as well. We also have 9 lakes listed as impaired for phosphorus and 1 impoundment. Similarly, here's the map showing the impairments for total cemented solids. Within this, there are 7 named streams and rivers, and then 1 impoundment. So this TMDL is going to be covering both phosphorus and sediment, and it's because we have these impairments on the river. So now I'm going to give you just a quick overview of the TMDL development process, which will also include the update of where we're currently at with this project. And before I dive into that, I just want to give a brief overview of what exactly are these TMDLs, what are we looking at, why are we doing this? So the EPA requires that we develop restoration plans for all the water bodies that are listed as impaired. As you saw in those previous maps, that includes a large number of river miles and lakes within this study area. And the TMDL stands for total maximum daily load. And this is just an evaluation of understanding the amount of pollutant a water body can receive and still meet water quality criteria. It's made up of this load we classify into 2 main groups. There are load allocations, which are really our non-point sources, waste load allocations, which is our point sources, which includes some of these larger municipal storm sewer systems. And then there's a margin of safety within the modeling, just a recognition that models are imperfect. So we want to make sure that we fully understand the picture and we're developing these restoration plans to reduce the loads to get these waters eventually meeting water quality criteria. So here's a quick overview of the development process. If you were here last year, you'll probably recognize the next following slides. But within Wisconsin, this is kind of the general procedure that we take for developing these TMDLs. So the first steps are modeling, monitoring, and conceptualization. The next step is modeling. Then we look at allocations, and then finally we look at the implementation piece. And I'll go through each of these in some detail. So the first phase that was completed when we met here last year is this monitoring phase. As part of this project, between 2019 and mid-2022, DNR did monitoring at 13 total sites. We also had some contractor support that was funded through EPA. This monitoring included chemistry modeling for monitoring for total phosphorus, total suspended solids, orthophosphorus, and also included flow measurements, which included stage and discharge. I have to give a huge shout out to my colleague Rachel Saber. She coordinated a lot of this work, and she and her team were out there a lot to collect these data. So I really, really appreciate all the work that you did for this project. And then where we were at last year was we had just kicked off the project and we had started into this conceptualization phase. And conceptualization you can think of really as what is happening in the watershed. So what does the land use look like? What does the climate look like? What are the soils, the topography, the slope? And then what is the hydrography, which essentially just means how are all these different lakes and rivers and streams connected? So a large part of this project was working with big data sets that are pretty readily available, but there are certain things that we can't glean from these large data sets, and that is really what's happening on the agricultural lands. So we sent out a very comprehensive survey to the county conservationists in those 4 main counties. And these covered everything from tillage practices to fertilizer applications. And these data were incorporated into this conceptualization phase, again, so we understand really what's happening on the landscape. And huge shout out to the folks who helped with those surveys, because they were very comprehensive, very lengthy, but they provide extremely important information for us as we go through the modeling phase, but also as we move into implementation. Yeah.
Which county did provide it to that data? Which county?
So Walworth, Racine, and Kenosha were the 3 big counties. Waukesha County also provided some input as well. So we completed those phases. We wrapped up this conceptualization phase at the end of last year. If you're interested in the details about the monitoring and this conceptualization, we did host a webinar in October, and you can find the recording of the webinar as well as 2 reports describing the results of the work that was done on our website. So if you go to DNR's website and just search into the search bar Foxil TMDL, FOXIL TMDL, it'll take you right to this page. So I encourage you, if you're interested, check out that webinar that was recorded. Now we're in the current phase, which is our watershed modeling phase. This shows everything on the left, these categories, that's really our conceptualization phase. And what we have to do is once we collect all these data, we have to pull that into a model to set the model up. And the model that we're using is it's called SWAT Plus. It's a soil and water assessment tool. The Plus is just a really comprehensive update that they made to the program. We used SWAT, the original version, for all of our other TMDLs. It's a really great tool for especially ungauged watersheds to understand what's happening, particularly from the runoff standpoint. And within this model that we have finally set up, there are the 7 main basins I mentioned. We have it broken down into 158 kind of sub-model watersheds, which includes 120 channels, 38 lakes and reservoirs, 26 point sources, and 38 permitted MS4s. And now that we've completed the model setup phase, we got the model set up around January of this year, we have to start looking at calibrating and validating this model. So it's pretty straightforward to incorporate these data into the model, but once you click that run button on the model, you want to make sure that it's actually representing what's happening in reality. And within the calibration and validation phase, we're looking at kind of these 5 main categories. First of which is water balance. We want to make sure that we're properly representing the amount of water that's running through the system. The second is crop yields. This is really important when we're doing this watershed modeling because crop yields kind of drive really a lot of the water balance and pollutant loading from the landscape. So when you have crops, they transpirate a lot of water. When you remove those crops, you're removing a lot of the nutrients from the system. So we want to get a good handle on what the crop yields are and make sure that aligns with what we've observed with data provided from a variety of sources. Then we want to understand flow rates. We want to make sure that, yes, we're collecting or we're representing the correct amount of volume through the system, but we want to make sure that water is passing through the system appropriately. Once we get flows calibrated, we'll look at sediment, and then finally we'll look at phosphorus. So currently, this is where I have spent a lot of my time over the last couple months. We're in the calibrating of the flows. And then once we complete the flow calibration, we'll move on to the sediment phosphorus. So once we have this model adequately calibrated and validated, we move on to calculating the baselines. And the baselines really just represent what is currently flowing through the system, what are our flows, also understanding what are the loads estimated by the model. And for this project, we're going to be looking at a period of 2011 to 2022 is kind of our established baseline. The reason we're using those 12 years, one, they're the most recent where we have the best data, and also we want to make sure that we have 2 full crop rotations for the model. Once we establish the baselines, we will move on to the allocation phase, and this is really where the rubber meets the road for the TMDLs. So we'll have our baseline loads that are estimated by the model, and we'll also have the flows that are estimated by the model. We'll use the flows along with our numeric criteria for phosphorus and our narrative criteria for sediment, and we'll be able to calculate allowable loads, which is really the TMDL. How much phosphorus and sediment can these water bodies receive while still attaining the criteria that DNR has laid out? And then the difference between what the current baseline load is and that available or the allowable load is really a measure of how much work do we need to do to get these rivers and lakes to criteria and meeting the water quality site criteria. And then the final step, which is really arguably the most important, is the implementation. We get this question a lot. It's like, why are you going through this huge modeling process? We know what needs to be done. We have to start implementing ag management practices. We need to have reductions from wastewater treatment plants. But the TMDL gives us a really good framework for implementing these management practices. So first of all, we can incorporate the TMDL limits into the wastewater permits. TMDLs provide additional support and context for existing implementation plans. And also, once we go through this process, we'll be able to prioritize these high-loading watersheds and locations. So this is just another way of looking at the summary of TMDL development. We're currently in phase 2. I'm not going to get too hung up on this because I want to save a couple minutes to talk about another consideration. And this has to do with the fact that, again, water bodies and watersheds don't care about these political boundaries. So what's happening in Wisconsin is going to impact what's happening in Illinois. And in 2020, the EPA approved the TMDL for the Illinois chain of lakes. And the Illinois chain of lakes is just on the downstream side, just on the other side of the border from Wisconsin. And as you can see from this map, a big portion of what's flowing into the chain of lakes is within Wisconsin. So the Illinois chain of lakes, Illinois has lake criteria for phosphorus of 50 micrograms per liter. And again, we need to make sure that what we are sending across the border from Wisconsin is able to meet those criteria and protect the lakes downstream. So this TMDL has been developed and approved by EPA. Once our modeling is completed for the Wisconsin portion, we will be performing a supplemental analysis that's based on our updated watershed model. Our time frame and our methodology is going to be slightly different than what Illinois did for their TMDL. So we're just going to do the supplemental analysis to make sure that we're consistent with kind of how Wisconsin does things and make sure that the models are appropriate for estimating total phosphorus in these chain of lakes. And this is very similar to what we've done in other TMDLs, specifically the Wisconsin River and the Upper Fox Basin TMDLs in Wisconsin have dealt with the situation where there's this downstream water body that kind of controls how much needs to be reduced upstream. So we have a lot of really good experience with this, and it'll be a very similar process. So if you're interested in kind of the approach and what you can expect the allocation process to look like, you can go to DNR's website and look for the Wisconsin River TMDL and the Upper Fox Wolf Basin TMDL. And to wrap up, I just want to give a huge shout out to the project team. Project coordination is done by myself and Kevin Kirsch, my colleague. Monitoring was performed by Rachel Saber and her whole team. Wastewater, I know Nick Lint is here, Nicole Kruger, our point of contacts there. For stormwater, Sam Catt and Pete Wood. Agriculture and urban non-point, Jesse Bennett. Modeling is what I'll be doing. So if you have any questions about specific parts of this project, please feel free to come up to me or reach out to any of these individuals if you're familiar and I've already worked with them. And finally, just to stay connected, you can check out our website. You can sign up for our Gov Delivery email list on our website. This will just give you updates about the project and future webinars that we may be hosting.
Thank you, Eric. So our next presenter is Pat Smarto, who is a landowner and a realtor, lakefront owner and a realtor specializing in waterfront properties. She is chair of the Fox Waterway Agency Advisory Committee, and I'm excited to hear about the agency's recently completed watershed plan, which I actually heard about last night too.
Very, very recently completed.
Back. Everybody watching at home.
I want to make sure that works.
Yeah, give me a second here.
Little technical difficulties.
It's my fault.